With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? A sphere S rolls without slipping with a constant speed on a plank P. Now the friction between upper surface at P and the sphere is sufficient to prevent slipping. Okay, while the lower surface P is smooth and rests on the ground. So this surface of P, this lower surface, this is smooth. Now initially P is fixed on the ground by a pin N. Now if N is suddenly removed, now if we are removing N, so what will happen? S will begin to slip on P, or P will be begin to move backward, or speed of S will decrease and its angular velocity would increase, and there would be no change in the motion of S and P. Okay, they would be at rest. Now if we just draw our this case, so what are the various things which have been given? Just we draw the FBD. So this is our block, upper block, and this is our plank. Okay, so what are the various forces which would be acting? So there would be a normal reaction in the upward direction on this, and there would be a mg downward. Now similarly here also there would be a normal reaction. Okay, but there is no use for the normal reaction, and in the downward direction it would be mg. Now in the horizontal we need to check. Now for example, if it is moving, okay, let's say this is moving in the forward direction with a velocity r omega, so there can be a frictional force in the backward or the forward direction. Let's just assume that friction is acting in the forward direction. Okay, so on this surface it would be acting in the backward direction. Now whether the friction force would be acting or not acting, we need to check this. Let's say the contact point is P. So what is the net velocity of Vp? So Vp would be equals to, what is the net velocity of this point? So there would be velocity in the forward direction, which is V, and due to angular motion there would be r omega in the backward direction. So what would be this is the point P. What is the net velocity? It would be V minus r omega. But we know that V equals to r omega. If we put the value of V as r omega, then this and this term would be cancelled because V equals to r omega. So our Vp would be equals to 0. That means the this would be the body will be instantaneously at rest on the plank. Okay, at this instant. So it would be at rest with respect to the plank. So if it is at rest with respect to the plank, then what is the value of the frictional force? Because frictional force opposes motion. Now with respect to this plank, it is not moving. The point P, the contact point, is not moving. It would be instantaneous axis of zero rotation. So if frictional force is not present, so this and this force is gone. So is there any horizontal interaction between the two? Is there any horizontal, basically, is there any force which is trying to pull it in the forward or the backward direction? No, because only the interaction between the two in the horizontal direction would be the frictional force. But due to the no relative velocity between the contact point, there is no frictional force. So if frictional force value is 0, so there would be no change in the motion. So if we see S will slip, no, it is wrong. To the P will begin to move backward. No, why it will move backward? If there was a frictional force value, then it could move backward. Now it will not move because there is no friction. Now the speed of S will decrease and its angular velocity would increase. Speed would not decrease, neither the angular velocity would increase because there is no frictional force to create the torque. Because if there is torque, then only we can increase the angular speed. So there is no friction, there is no torque, so there is no change in the motion of S and P would be remains at rest. So D would be the correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.